Imagine a lock so complex. It would take the most powerful supercomputer on Earth 10 billion years to crack it. Now, imagine a machine that opens that lock in 3 minutes. This isn't science fiction. It is the end of the digital world as we know it. We aren't just building faster computers. We are rewriting the laws of physics. But what happens if this power falls into the wrong hands? It won't just be a breakthrough. It will be the ultimate weapon. For 50 years, humanity danced to the beat of Moore's law. We shrank transistors until they were smaller than a virus. But we've hit a wall. The world of zeros and ones, classical computing, has reached its physical limit. Want to simulate a molecule? Cure cancer? Classical computers fail here. Why? Because to solve the universe's true problems, they would need more memory than there are atoms in the universe. We need a new logic. Enter the quantum realm. Warning: here, the rules of common sense do not apply. Think of a classical bit, like a light switch, on or off. Boring, predictable. But a qubit, that's different. Thanks to superposition, a qubit can be on, off, and everything in between simultaneously. Picture a spinning coin. Is it heads or tails? It's both. This allows quantum computers to analyze a billion possibilities, not one by one, but all at once. It gets even weirder. Einstein famously called this spooky action at a distance. We call it entanglement. Imagine two particles linked across the universe. Change one, and the other changes instantly. Faster than light. No wires, no signals, just pure connection. When we chain these entangled qubits together, we don't just get a faster calculator. We get a machine that thinks in the multidimensional language of nature itself. But why does this matter for artificial intelligence? Because today's AI is actually blind. To recognize a cat, it has to look at millions of photos. Think of AI as a hiker trying to find the lowest point in a vast, foggy mountain range. A classical computer walks down the hill step by step. It gets stuck in valleys. It gets lost. Quantum AI doesn't walk. It tunnels. Instead of climbing over the mountain, it simply passes through it. It explores every possible path simultaneously to find the absolute best solution. This means discovering drugs in days, not decades, creating materials that don't exist in nature, or shattering the encryption that protects every bank account and nuclear code on the planet.
are witnessing the dawn of a new Cold War. But this time, the race isn't for nuclear missiles. It is for quantum supremacy. Experts don't shout about it. They whisper. They call it Q-Day. The inevitable moment when a quantum computer becomes powerful enough to break all global encryption instantly. On that day, the winner won't just read their enemies' emails. They will control power grids, financial markets, and military satellites. It will be the ultimate checkmate.
But we have to pause and ask, is this imminent, or is it just expensive hype? The history of AI is filled with winters, periods where big promises failed and funding dried up. Quantum computing faces the same risk. These machines are incredibly fragile. Maintaining a state of superposition is like trying to balance a pencil on its tip during an earthquake. One slight vibration, one change in temperature, and poof, the calculation is gone. If we can't solve this noise problem, the bubble might burst, leading us into a long, cold quantum winter. Winter or not, the code is being written right now. The race for quantum AI is not just about speed. It is about control. Control over data, biology, and the truth itself. The winner will define the next century. Will this technology cure our diseases? Or will it build a surveillance state so perfect that escape is impossible? For the first time in history, the hand holding the pen might not be ours.